Just a couple things having to do with exponents and logs. We need to be comfortable with the graphs. And so let's do 2 to the x first. 2 to the 0 is 1. So that's easy. 2 to the first is what? 2. 2 to the second is going to be 4. 2 to the third is going to be 8. And it'll just skyrocket out of sight. But when we go the other way, it's going to go 1/2, then a 4th, then an 1/8. Will it ever get to 0? Will it ever touch the 0? No, it won't. So my domain is just going to be all reals. No problem. Any x we can put in. But the range is going to be y greater than what? 0. By the way, when we go to negative infinity, what's this y value getting close to? 0. And then when x goes to infinity, it's going to go to infinity. So that's 2 to the x. Would you show me with your arms? 2 to the x looks like this. Would you, with your left hand, go really close to 0? Your right hand goes up, and your sternum is what point? 0, which is 0, 1. Okay, that 2 to the 0 is 1. Next. Now we're going to do the opposite. This time we're going to use a to the x, but it's going to be 1/2 to the x, or 1/4 to the x, or 1/8 to the x. But all that's happening here is that this is 1 over 2 to the x, or 2 to the negative x. These are all the same thing, right? So when you go 2 to the negative x, what's 2 to the 0? 1 again. And then what's 2 to the 1? Well, negative 1 is just going to be 1/2. 2 is going to be here. And so this is going to go that way. And negative 1, 2 to the negative 1 is 2 to the 2. And then it's going to be 2 to the 4. And it looks like that. So show me 2 to the x. Show me 2 to the negative x. Flips this way. There you go. And so when x goes to negative infinity, it goes up to infinity. When x goes to positive infinity, it goes to 0. So my domain is the same as before. The range is the same as before. And that's exponential function 2 to the negative x. All right, and let's talk about it quick. Take your calculators out. And, okay, we're going to just do one of these word problems having to do with decimals. Decibel is a way of looking at huge ranges. Like the ranges from like 1 to, this is 10 billion, 1 to 10 billion. Well, how do you look at that? 1 to 10 billion is too much. It's too big. So instead of going 1 to 10 billion, we look at 1, 10, 100, 1,000, 10,000. We go powers of 10. 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4. That is going to narrow what we look at. This is called a log representation of huge numbers. And so the formula we use is to bring this down so there isn't such huge numbers. So let's start first. Do you know what 10 to the negative 12 is? It's the threshold of hearing. You can barely hear this sound if you listen very carefully. Can you hear my voice? Hold up 4 fingers if you can hear my voice. That's the threshold of hearing. Nice. 10 to the negative 12 watts per square centimeter is what they call the threshold of hearing. In your formula, we're always comparing to that really soft threshold of hearing. Go like this. When we go to louder sounds, we use higher exponents of 10, like 10 to the 6th, or, I won't do it anymore. It's probably bothering the rest. If you go to the airport, they're around 10 to the 10. So jackhammers are like 10 to the 11. Anything over 10 is going to damage your hearing. Inside your ear are these little tiny cilia that vibrate next to resonant sounds of certain pitches. So if you want to hear a C, this is the little hair cilia for a C. This would be like a C sharp. I mean, I'm thinking of it in terms of music, but it's different frequencies of sound. If you go to a rock concert and you play the music, or in your car, how many of you have music in your car? Really loud? What happens is you break these cilia, and so you can't hear that ever again. You won't hear that frequency. So old people can't hear very high frequencies or very low frequencies. They can hear kind of in the middle because they've busted up all of these. And what you want to do is to save your hearing is not to listen to anything over 10 to the 10. 10 to the 10 is when it gets really serious. And most people listen to music at 10 to the 11, 10 to the even 12 in their cars real loud. Listening in your car is very dangerous. Same thing in a concert. If you go to a concert, save your ears, wear earplugs, you will hear and enjoy the music just fine. But you'll also save your ears too, so your hearing. All right, so for the Richter scale, we're looking at a huge, huge, huge expanse. 10 to the negative 12 is what we're comparing to. I'm sorry, decibels. 10 to the negative 12 is what we're hearing to. We want to find out what this 10 to the negative 6 is. So we're going to put in what is the intensity if we put in for I 10 to the negative 6 over 10 to the negative 12. This is easy, 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 but it's going to look really nasty. How many of you think that looks nasty? Looks nasty, doesn't it? But what is the difference between 10 to the negative 6 and negative 12? What's the difference in those powers? What is negative 6 plus 12? 6, right? So this whole thing, the whole point of it is to say that this difference is log base 10 of 10 to the 6th. This is 10 to the 6th. 10 to the negative 6 minus the negative 12 is 10 to the 6th. Is that part okay? So what is log base 10 of 10 to the 6th? Well, it's going to be 6. So the whole point of this whole thing here is to be 6. It's 6 exponents of 10 above 10 to the negative 12. And decibel means they like the scale times 10, so this is going to be 60 decibels. 60 decibels is like yelling at each other for sound. Okay, then we get to next one. It says damage to your hearing can resort from short-term exposure to around 115 decibels. What intensity is needed to produce this level? So if you have 115 decibels equal to 10 log I over 10 to the negative 12. We want to solve for I. So we're going to divide by 10. And you're going to get 11.5 equals log base 10 of I over 10 to the negative 12. Okay? And I have no idea what to do next. I'm stuck. I don't know what to do after this. Do you? We're stuck. What does this mean? Hold your fingers up like this. What does this mean? Secret to logs. What's the secret to logs? If you think you're stuck, what should you do? Change the form. So change this 10 to the 11.5 equals I over 10 to the negative 12. And then when we solve for that, you're going to get 10 to the 11.5 times 10 to the negative 12 equals I. Add the exponents. What is 11.5 minus 12? Negative 0.5. This is going to be your intensity. That doesn't sound like much, but it is enough to do damage. And I'm going to stop there. This one's you can do on your own. Okay? So maybe we should have you start this one. The pH of a solution is measure of acidity. The formula pH is equal to negative log. When you don't see a base, what is it when you see log? Base 10. There you go. And then you put in the hydrogen ion concentration in for this. So using this formula, see if you can answer these A, B, C, and that's your homework for tomorrow.